Okay, in lecture 18, we need to talk about a picky language detail called conditional compilation and macro guards. First of all, we're going to review what compiling actually consists of, and I've drawn a diagram of this before. When you run your compiler on a C++ program, there's actually three phases that take place. The first phase is pre-processing. Okay, so you start out with your program file, prog.cpp, whatever it is, and when you run that through your compiler, the first step is that gets passed through a pre-processing phase, and the preprocessor is responsible for handling things like include directives or define directives that we talked about a couple of lectures ago. The output of the preprocessor is a human-readable document called the translation unit. Now, the translation unit is usually not stored on disk, although depending on what compiler you have, you may be able to request that it be stored. Generally, the translation unit simply gets fed into the compiler, and it's the compiler that produces binary executable code, that is so-called object code, as its output. Finally, this object code file, as well as the other object code files that you may have compiled in the same command, are linked together with precompiled object code pulled in from libraries, resulting, assuming that everything has gone correctly, in an executable program file. Okay, so we've been using include directives for standard library headers like iostream and fstream and string and cstandardlib and ctime and others. And we've talked about what this include directive does. Basically, it causes an entire copy of that header file to get sucked in place of the include line. In addition to pound include, there are other directives that the preprocessor also handles, and the result of the preprocessing, as I've said, is a translation unit. The pound define directive, as we mentioned before when we were talking about const, can be used to define a token to be replaced by some sequence of characters. We previously saw this example of defining the token pi to be replaced by this sequence of characters, 3.1415926, etc. Here I'm also defining the token dim to be replaced by the sequence of 4 characters 1000. When the preprocessing phase of compilation processes this code, the token dim is replaced with the number 1000. The token pi here is replaced with 3.14159, etc. And the token dim is also replaced here with 1000. Nowadays, you can achieve these same purposes of array dimensioning and loop control and specifying special values like pi using const rather than define. But we still need to use pound define in order to handle what's called conditional compilation. The idea here is that you can compile in certain lines of code depending on whether some certain token has appeared in a pound define. We use pound ifdef to test whether a certain token has been in a pound define directive. We use ifndef to test whether a certain token has not been in a pound define directive. So here we're including, this is our first directive, we're including a file named defs.h. Perhaps that file is full of pound define directives, and maybe pi was defined in one of those pound defines, or maybe not. As we continue scanning through the rest of this code with the preprocessor, if the token pi has been pound defined, then this statement here is passed along into the translation unit, and this next cout statement down here would not be passed on to the translation unit. Okay, so that is, if pi has been pound defined, this cout statement is passed on to the compiler. But if pi has not been pound defined, then this statement has passed on to the compiler. So we can use ifdef and ifndef to select which lines of code should be passed on to the compiler and which lines of code should not. In addition to using ifdef and ifndef to control conditional compilation, there's also a poundif directive that evaluates whether a certain expression is true, that is, whether a certain expression is non-zero. So the idea here is if size of long is 4, the statement that gets passed along to the compiler is cout of the string probably 32-bit processor. elif means the obvious thing, else if. So elif size of long is 8, we're going to pass along to the compiler cout of probably 64-bit processor. And then else means, again, the obvious thing. So if size of long is not 4 and size of long is not 8, we're on some kind of weird processor, and we're going to pass that statement along to the compiler. By the way, notice that ifdef, ifndef, and this if chain all end with and if. Okay, now we're going to take a look at an actual translation unit as produced using the GNU C++ compiler. We have a header file, FoodH, consisting of exactly these 3 lines. There's a comment line giving the name of the file. There's a pound-define directive defining the token pi to be replaced by that sequence of characters. And there's a function declaration with a comment. In this code file, foo.cpp, these are the lines of code that exist. The first line is a comment line. The second line is an include of foo.h. So literally, when the preprocessor gets to this pound include, that line, pound include of foo.h, is replaced by these 3 lines: the comment, the pound define of pi, and the declaration of ABC. Then the preprocessor simply passes the int main line and the open curly brace line along to the translation unit. When we get to here, ifdef of pi, the preprocessor discovers, oh, pi was the subject of a pound define. Therefore, these next 2 lines here will get passed along to the translation unit, and the 2 lines between the pound else and the pound endif will not be passed along to the translation unit. So, in a nutshell, because pi was in a pound define in foo.h, these 7 lines in foo.cpp, starting from ifdef pi down to endif, are going to be replaced with just these 2 yellow highlighted lines. Following that, we're going to call the ABC function, and its return value will be stored into the variable m. And below main, we have the full definition of the ABC function. Now, we're allowed to call ABC above its definition because the declaration for ABC was pulled in as part of the include of foo.h. Okay, so let's see now what actually happens when we compile the foo.cpp file and the preprocessor processes that file. Here's the output that we get from the GNU C++ compiler, and I've used the -E option to say that I do want to see the translation unit produced by the preprocessor processing through that foo.cpp file. Okay, so on slide 10, these lines that start with a pound sign and a number, you can really ignore. Those lines are simply telling the compiler which line and which file we are currently processing, so that if the compiler discovers some kind of error, it can report the error to include which line of which file the error occurred in. Okay, so these first 4 pound 1 lines are simply indicating to the compiler that we are currently in line number 1 of the foo.cpp file. Now, right here where I'm waggling my cursor, I'm not able to highlight anything there, unfortunately. That is the blank line that results from the preprocessor trimming out this comment. All right, it turns out that the preprocessor is responsible for trimming out comments as well as for handling things like pound include, pound define, pound if def, and so on. So that blank line is the result of the comment being eliminated. Then we get this message saying, oh, by the way, now we're in line 1 of the FoodH file. And you may recall, let me pull it back up on the right-hand slide. FoodH has 3 lines in it. And here are those 3 lines. Now, again, I can't highlight any of these except for the last one of the 3 lines. But the first line in FoodH is a comment, which is simply eliminated by the preprocessor. The second line is a pound define of pi. That doesn't actually pass any information on into the translation unit. The preprocessor simply knows now, from this point on, where it sees the token pi, it should replace that token pi with this sequence of characters, 3.1415, etc. Okay, so those are the 3 lines from FoodH that are passed on to the translation unit after the preprocessor has included FoodH and processed its lines. Now we are back in line 3 of the foo.cpp file. Okay, so line 1 was a comment, which is now gone. Line 2 was the include of foo.h, which put these 3 lines, 2 blank lines and a declaration, into the translation unit. Now we're back in line number 3, and there's nothing that the preprocessor needs to do with int main. It does strip out this comment and passes the line with the comment removed to the translation unit. Continuing on, the next line is the open curly brace. Okay, so that's this line here. Then we get to the if def of pi. Now, the preprocessor knows that pi has been defined. That particular if def line comes through to the translation unit as a blank line. So here again, I'm wiggling my cursor in the position where that blank line occurs. That's where if def pi was. Then, because pi was pound defined, these next 2 lines, const char star message double pi, get passed directly through to the preprocessor. Notice that the token pi in the line double lowercase pi gets uppercase pi, that token has been replaced in the translation unit with the sequence of characters that pi was pound defined as. This occurrence of pi in the string pi is defined, that pi is not a token because the entire string is treated as a token. And that entire string just happens to have the 2 characters, capital P, capital I, within the string. Now, nothing gets passed through the translation unit for pound else and the 2 lines following pound else and pound end if. So it looks like a little more than 4 lines here, but I promise you there are 4 blank lines here, followed by the line int m gets the returned value from abc of 5.9. Then we have the closing curly brace at the bottom of main, and the definition of the abc function. Okay, so to say that again in summary, the preprocessor includes headers, strips out comments, defines tokens to be replaced by strings, and then conditionally passes some lines through to the translation unit to be compiled, and in this case does not pass other lines through to the translation unit. Okay, so why do we care about this translation unit stuff? What does it have to do with us? Well, remember, we have been creating headers describing things like stocks and employees and managers. A class definition, such as the stock class definition here, can only appear one time in the translation unit for a file being compiled. So here on slide 12, we have our stock header with the class stock definition and some public members and a private price. if I now write an application program, stockapp.cpp, and I make the mistake of including stock.h 2 times, then the first time stock.h is included, that's fine. The contents of this header will be included, the comments will be stripped out, and what I will have in place of this include of stock.h is class stock open curly, public, stock default constructor, set price, get price, private, double price, and the end of the definition, close curly and semicolon. So far, so good. But if I make the mistake of including stock.h a second time, then the compiler is going to see class stock being defined again, and I'll get an error from the compiler telling me that class stock is already defined. And this is a problem. Well, your first reaction looking at this might be, well, okay, so dummy, don't include that same header file twice. But that's a little bit easier said than done. Let's suppose that I am writing an application using stocks and using options. Now, because I'm using stocks, I'm going to want to include the stock header. And because I'm using options, I'm going to want to include the option header. The problem that I have, though, is that at least some options are going to be defined in terms of stocks. So it's almost certain that the option header also includes the stock header. Okay, so here I have a situation where, in effect, I'm including the stock header 2 times, but I, developing this application, don't happen to know that. The option header does have to know about the stock header, but it should not be my responsibility as the application developer to have to know which headers include which other headers. If I want to use stocks, I should include stock.h. If I want to use options, I should include option.h, and everything should work. Okay, so here on slide 15 is the problem that I was describing verbally. In the option header, the first thing I'm doing is including the stock header because I'm going to be developing options in terms of underlying stocks. Well, to eliminate this problem of classes being defined multiple times, I can use what are called macro guards, involving a combination of if-endef directives and define directives. These macro guards ensure that if you include a given header multiple times, only the first include will have any effect, and the other includes will simply be replaced by a bunch of blank lines. Let's see how that works. Here is a macro guard for our stock header. We say if-endef, and then this is a common example of a name that people might use for their macro guard. Since this file is called stock.h, we're using the name underscore stock underscore h underscore in all caps. All right, so if that thing is not defined, then we're going to define it. And we'll provide the full definition for our stock class. And here's the endif at the bottom of the if-endef. Now, having put this macro guard into place for stock header, when we include the stock header the very first time, underscore stock underscore h underscore will not be defined. Therefore, I'm going to define it and pull in the definition for the stock class. The second time I get down to including stock.h, we'll discover that underscore stock underscore h underscore is defined, and so all of these lines between the if-endef and the endif will simply be replaced with blank lines. All right, so the first include gives me the class stock definition. The second include just gives me a bunch of blank lines. And the third include gives me a bunch of blank lines, and so on. So now, as an application developer, not only do I not have to know that the option header includes the stock header, but I even don't have to worry about whether I've accidentally included the same header more than once. Okay, I can include stock.h either directly or indirectly as many times as I want, and only one is going to take effect. All right, so we did have to describe an awful lot of machinery to get to this business of defining and using macro guards around headers to prevent errors if those headers are either directly or indirectly included multiple times. You'll discover that many C++ compilers provide #pragma once as an alternative to using macro guards, but this is not in the standard, whereas macro guards are in the standard, and it's not universally supported. So I would urge you to stay away from using Pragma once, but you should know what it means because it is likely that you will see it in other people's code. All right, so that gets us to the conclusion of conditional compilation and macro guards.